Hi students, welcome to today's class. Today I am going to explain the topic number of rational terms in a binomial expansion. What is meant by that rational terms or irrational terms? Let us see that. For example, if you take a binomial, for example, cube to root of 8, otherwise cube to root of 9 and fourth root of 5 whole to the power of 100. In this expansion, there are certain rational numbers will come, some irrational numbers will come. I know you know that what is irrational numbers. So this is a root 3, root 2, root 5, cube root of 5 or fourth root of 10. All these are irrational numbers. The numbers which are not irrational are rational numbers. Okay, we know that. So some terms you will get this type of irrational number terms you will get, some of rational number terms you will get. Now we are going to see the number of rational terms and irrational terms. Of course, in this total 101 terms will be there. So this is 101 terms. So some are rational numbers and some are irrational numbers. Okay now. So if you know the rational numbers, you know how to find out irrational numbers. Just subtracting from 101. Okay now how to find out that? So shall we do expansion? In this expansion, there are 101 terms will come. 101 terms will come, then in 101 terms we have to identify, we have to count which is a rational, which is irrational, which is rational, which is irrational. It takes so much time. Okay, so without doing all those expansions, how to find there are how many number of rational numbers are there in a binomial expansion. Let us see that formula. Okay now, hi students, welcome to this concept. The number of rational terms in a binomial expansion, this is a formula. So you remember the formula like this. First, the first term is a power 1 by L and the second term is a b power 1 by k whole to the power of n. Understand this? Here two cases arises. What is the first case is? Observe here L and k. L and k. Observe L and k. If none of L and k is a factor of n, that means L is not a factor of n and k is not a factor of n. First you have to check whether L and k are factors of n or not. If none of the numbers is a factor of n, that means L is not a factor of n, k is also a factor of, k is also not a factor, none. So here none is not a factor of n, then the number of rational numbers is given by, this is a greatest integer function. You know in function greatest integer function. That means if you got here 6.5, you have to take 6. If you get the value of 7.5, you have to take the value 7. That is n by, so that is equal to n by LCM of L and k. LCM of L and k you have to take. Okay now. After finding the value, if it is an integer, okay, that many terms come. If it is a fraction, only the fractional also, the integral part only you have to take. Next. Now, second case arises, at least one of L and k is a factor of n. That means what? At least either L is a factor of n or k is a factor of n. If L is a factor of n or k is a factor of n, then the number of rational numbers is equal to the same answer plus 1. Plus 1 you have to add. Okay now, if none of L and k is a factor of n, the answer is number of rational numbers is a n upon LCM of L and k. If at least one, either L or k are the factors of n, at least one. If both are there, happy. If at least one is a factor of k, then the number of rational numbers is equal to greatest integer function of n upon LCM of L and k plus 1 you have to add. Understand this? So this is the concept that is a number of rational terms in this concept. Okay. Now let us see one problem based on this so that you can understand this concept very easily. Okay now. Welcome back to this problem. The number of rational terms in the expansion of, so what is that expansion? The expansion is 8th root of 5, 6th root of 2 whole to the power of 100. So you write it as a 5 to the power of 1 by 8 2 to the power of 1 by 6 whole to the power of 100. In this expansion, there are 101 terms are there. In that 101 terms, there are some rational numbers will be there, irrational numbers will be there. So then how to find out the number of rational numbers? See here. So just the concept we explained here. 8 and 6. 8 is not a factor of 100. 6 is also not a factor of 100. Both 8 and 6 are not the factors of 100. Then the number of rational numbers in the expansion is given by, number of rational numbers in this expansion is given by greatest integer function, that is greatest integer function, and 100 by n by LCM of 8 and 6. LCM of 8 and 6. So that is equal to greatest integer function by LCM of 8 and 6. What is the LCM of 8 and 6? You know in the lower classes. So this is a 2 4s are, 2 3s are, 2 4s are 8, 8 3s are 24. So this is equal to 100 by 24. 100 by 24 is equal to how much? 24 4s are, 4 4s are 8, 96. So 96 point something. That means what you will get here? This is a 4 point something you will get, that is equal to 4. So greatest integer function of 4 point something is equal to 4. Therefore, in this expansion, there are how many rational numbers will be there? 4. Then how many irrational numbers will be there? Irrational numbers means total number of terms are how many? 101. 101 minus 4, that is equal to this is a 97. 97 irrational numbers will be there, 4 rational numbers will be there. Understand this? Okay. Now the question arises, sir, if you don't know the formula, then how to do this? For example, in binomial theorem, there are so many terms, so many problems are there. Sometimes if you don't know the formula, so then how to do manually? That also you should know. Okay, sometimes. Okay. So now I am going to do without using this formula. But actually, if you know remember the formula, so it's a very nice. Sometimes if you are unable to remember the formula, then how to do the problem? Just we will find out the general term. We will proceed that. Okay. So now I am going to explain the general method to find the number of rational terms. Welcome back. Now I am going to tell a general method of finding the number of rational terms in that expansion. So let us see that. First, to find out the general term. TR plus 1 is equal to formula NCR 100 CR 8 root of 5 whole to the power of 100 minus R into 6th root of whole to the power of R. Understand? So NCR into x to the power of n minus r into y to the power of r. So this is equal to 100 CR, fifth root of fifth power. This is equal to 100 minus r by 8 into this is a 2 to the power of r by 6. Okay, now 5 to the power of 100 minus. So this is a 5 to the power of 1 by 8. No, this is a 6th root of 2 means 2 power 1 by 6. That is a r by 2. Now to make it is a rational term, so this 100 minus r and r should be divisible by both 8 and 6, so that you have to get some integer terms you have to get. So for that let us check one by one. So let us take r is equal to 12. That is also I will tell. What is the LCM of 8 and 6? 8 and 6 LCM is 24. So you start from 24 here also. For 24 before number 12. Let us check r is equal to 12. Let us check r is equal to 12. 12 by 6. How much? 2. Here also 100 minus 12. So 100 minus 12. This is equal to 88. 88 by 8 cancels. 88 by cancel. So r is equal to 12. Next add 24. So this is equal to 36 also will be there. 36 by 6. It will be cancelled. 100 minus 36. 100 minus 36. This is a 4. This is a 9. So this is equal to 64. 64 by 8. 8. So cancellation will take place. Again add 24. So this is equal to if you add 24, so 36 plus 24, 60. Again I add 24, so this is equal to 84. Okay, now let us check. 84 will be cancelled by 6. 100 minus 84, so that is equal to 16. 16 by 8 will be cancelled. So if you add again 24, so if you add 24, 84 plus 24, 8, 108. 108 will be 100 minus 108. Again this something 1 by 5 will come. Again you will get a rational number. Okay, so that's all only. So how many for R, how many values we got? That is equal to 1, 2, 3, 4. For 4 values, so you will get rational numbers. For 4 values, you will get rational number. That means you have to verify. So let us take R value is so 8 and 6 LCM is 24. So you better start from 12. If it is possible, you can start with 12. We cannot start with the 6 also, you can start. Whether if it is possible, you can take it. So first to find out the first number 12, then what is the LCM that you add, going on add until you get only positive number. So this is a general method of finding the number of rational terms in this expansion. Okay, now so I will explain one more problem. Okay, so here both 8 and 6 are not the factors of 100. Now I am going to explain another problem. Okay, welcome back to this concept. The number of rational terms in the expansion of square root of 3 plus fourth root of 5 whole to the power of 124 R. So let us see the solution. So this is a square root of 3 plus fourth root of 5 whole to the power of 124. So this is equal to square root of 3 means 3 power 1 by 2. Fourth root of 5 means 5 power 1 by 4 whole to the power of 124. Understand this? Very nice problem. See here, 2 is a factor of 124. 4 is also a factor of 124. Not only both the terms, at least one term is a factor of that n. Then what is the number of rational numbers? Sorry, rational terms. Number of rational term is the greatest integer function. That is a 124 by LCM of 2 and 4. So I am writing the formula LCM of 2 and 4. Plus 1 you have to write down. Understand? So if it is a none of the numbers is a factors of that n, then no need of plus 1. Now you have to write down plus 1. Now, so this is equal to 124 by what is the LCM of 2 and 4? Least common multiple is 4. Plus 1, that is equal to 4 3s are 4 1s are. So step of 31 plus 1, that is equal to 32. Therefore, you will have a 32 rational numbers. Number of rational terms we have 32. So how many irrational numbers means 125 minus 32. 125 minus 32. That is equal to 393. Irrational numbers, 32 rational numbers. So 32 rational numbers, 93 irrational numbers you will have. Okay, now. So I hope that you understand this solution. Okay. So if you don't know the formula, how to find out the general method means just a previous problem I explained. Find the general term TR plus 1, so NCR x to the power of n minus r, y to the power of r. Then like that you would count. But if you see that this is a very somewhat difficult to count out. In the previous problem there are only 4 terms are there, but here you will get 32 terms you will get. Up to 32 you are going on substitute and verify like that you will do. Okay, now better you remember this formula. Okay, so if you are unable to remember the formula, just go for general method. Okay, so there is no way. Okay, I hope that you understand this concept. So let us go for next concept. Hi students, welcome to this concept. So in this concept I am going to explain a very linkage of 2 concepts. One is a integration, that is a calculus in algebra. Understand? So integration belongs to calculus and the binomial theorem belongs to algebra. Okay, then how to linkage these 2 concepts? Let us see in this problem. Okay, so here if 1 plus x whole power n is equal to sigma r runs from 0 to n CR x power r. Don't be confused about by seeing this expansion. by seeing this notation. We know that 1 plus x whole power n expansion. Okay, keep it like that. Then show that c naught plus c1 by 2 plus c2 by 3 plus so on cn by n plus 1 is equal to 2 to the power of n plus 1 minus 1 by n plus 1. That we have to show that, but there are different methods are there to prove this result. But the easiest method is using integration. Okay, na? So let us see that method here. Okay, so see the solution. First to write the expansion of 1 plus x whole power n. So this is given by c naught plus c1 into x plus c2 into x square plus c3 into x cube plus so on cn into x power n. That is the expansion of 1 plus x whole power n, where c1 stands for nc1, nc2, nc3, so on. Now what I am going to do is integrate between the limits 0 to x. Integrate the above function both sides with from 0 to x. Now what is the integration of 1 plus x whole to the power of n? We know that this is a 1 plus x whole to the power of n plus 1 upon n plus 1. So the limits are from 0 to x. So what is the integration of c naught constant? That is equal to c naught x plus c1 into x square by 2 and c2 into x cube by 3 and c3 into x power by 4 plus so on cn into x power n plus 1 by n plus 1. Here the limits are from 0 to x. So what I did integrating on both sides. So the upper limit is x, wherever x is there substitute x, the lower limit is 0, wherever x is there substitute 0. Now so what is the upper limit means same term will come. 1 plus x whole power n plus 1 upon n plus 1 minus, if you substitute 0 here, 1 plus 0, 1, 1 to the power of n plus 1, 1 by n plus 1, 1 by n plus 1. This is equal to, substitute upper term x, upper limit x. So same terms will come, c naught x plus c1 x square by 2 plus c2 x cube by 3 plus so on cn into x power n plus 1 by n plus 1 minus, if you substitute 0, see here in each term 0 is there, 0, 0, 0, 0. So therefore lower limit total 0 will be there. So no need to write down. Now this is one of the result. This is one of the result. So take LCM 1 plus x whole power n plus 1 minus 1 by n plus 1. This is one of the result. Okay, now in this result put x is equal to 1. Put x is equal to 0. Otherwise we want x is equal to 1 only you have to put. Why? Because here 2 to the power of n plus 1 you have to get. Put x is equal to 1 here, 1 plus 1. Total LCM is n plus 1, 1 plus 1, 2 to the power of n plus 1. These factors you will get 2 to the power of n plus 1 minus 1 by n plus 1. See here c naught plus c1 1 by 2, c2 1 by 3, so on cn 1 by n plus 1 will get. Okay, now so this problem will be done very easily. So if you put x is equal to minus 1, you will get another result. If you get x is equal to minus 1, you will get another result. The result is if you put minus 1, so this is equal to 0, this is minus 1 by n plus 1, and you will get alternate plus and minus you will get. Okay, now so this problem will be done using integrating from 0 to x. Okay, now so I hope that you understand this solution. Let us go to one more problem. Welcome back to this problem. Prove that c1 by 1 minus c2 by 2 plus c3 by 3 minus c4 by 4, that means alternate plus minus, so on cn is equal to 1 plus 1 by 2 plus 1 by 3 plus so on 1 by n. Okay, now so that we have to prove. Let us see that. Here also we will make use of the integration. Where in it, at which stage we will use means we will see that. Solution you see here, let us Sc is equal to c1 by 1 minus c2 by 2 plus c3 by 3 minus c4 by 4 plus so on minus 1 whole power n minus 1 by n into cn. Okay, now let us put it like that. So let us take the expansion of 1 plus x whole power n expansion. So what is the 1 plus x whole power expansion? c1 into x plus c2 into x square plus so on cn into x to the power of n. Cn into x to the power of n. Let us see that expansion. Now divide with x on both sides. Divide with x on both sides. 1 plus x whole power n by x is equal to c naught by x plus c1 plus c2x plus c3x square plus so on cn into x to the power of n minus 1. Okay, now I am dividing with x on both sides. Let us bring this term to this side. So this is equal to 1 plus x whole power n minus c naught by x here also x is there. This is a c1 plus c2x plus c3x square plus so on cn into x to the power of n minus 1. So I have taken this first term to left hand side. So take the LCM x. So this is equal to 1 plus x whole power n minus 1 by x here. 1 plus x whole power n minus 1 by x here. So if you observe here, so what is the, of course, this whole thing as it is will come. 1 plus x whole to the power of n expansion is what? This is the 1 plus x whole to the power of n expansion. So you have taken that this side. So let us this write this as a x as a 1 plus x minus 1 you write down. There is any wrong here, plus 1 minus 1 will get cancelled. Now let us 1 plus x whole power n by minus 1 by 1 plus x minus 1 expansion. So if you do the expansion of this, let us see what you will get. Okay, now sorry, let us continue the problem. So what is the expansion of this 1 plus x whole power n minus 1 by 1 plus x minus 1? So if you see this expansion, you will get 1 plus x plus we have 1 plus x square, so on 1 plus x whole power n minus 1. So this expansion will get, we have a formula x power n minus 1 by x minus 1, x power n minus 1 by x minus 1, that is a 1 plus x square plus so on x to the power of n minus 1 formula is there. Let us see that. So that is same as it is c1 plus c2x plus c3x square so on cn x power n minus 1. Now let us integrate both sides. Integrate both sides from minus 1 to 0. Integrates both sides. This is a definite integration. So there is now what is the integration here? X. Here 1 plus x whole square by 2, 1 plus x whole cube by 3 plus so on. This is a 1 plus x whole power n by n. So this is equal to upper limit minus 1, lower limit is 0. So here c1x plus c2 into x square by 2, c3 into x cube by 3 plus so on cn into x power n by n. So this is equal to upper limit minus 1, lower limit is 0. Understand this? Upper limit, lower limit. Okay, now let us substitute here minus 1. So from 0 to minus 1, let us, sorry, minus 1 to 0, not so this for here minus 1, no, minus 1 to 0. So this is a minus 1 to 0. The lower limit is minus 1, upper limit is 0. Okay, now if you substitute here in each term, you have 0. Each term you have 0. Therefore, the upper limit part will become 0 and the lower limit part is already minus of will be there. No, here minus 1 will come. So here how much here? Here 0 will come. Here 1 minus of minus 1 plus x whole cube, that also 0 will come. And ultimately, so what is the thing that you will get here? Here upper limit is total 0 will come and the lower limit is here minus plus minus will come. Okay. So upper limit is 0 and the lower limit is minus 1. Upper limit is 0 and lower limit is minus 1. Substitute upper limit is 0. If you substitute upper limit 0, all will get 0 minus of substitute this x value minus. If you take minus common outside, so you will get that this expression only you will get, that is c1 by 1, that is a c2 by 2 plus c3 by 3, so on you will get a minus 1 whole power n minus 1 by n into cn. That is equal, that term I am writing, why? Because it is left hand. Now coming to right hand side part, substitute 0 here, 0, this is a 1 plus 0, that is a 1 square by 1 by 2, 1 by 3, so on 1 by 4 you will get upper limit and minus lower limit. That means here minus 1 you will get. then you will become already minus is there, no, plus 1 will come and remaining all terms will become 0. Then you will get 1 plus 1 by 2 plus 1 by 3, so on 1 by n. So like that you can find out this. So this is the problem completely based on integration. Okay now. So I hope that you enjoyed today's class. So let us see some more problems in the tomorrow's class.